Have you ever thought about the biggest number? It's a question that can really get your mind spinning. It's a fun question with a mind-blowing answer. The concept of the biggest number is more complex than it seems. Numbers, you see, never end. We say they're infinite. This means there's no final number, no endpoint. That doesn't mean infinity is a number though. It's not something you can write down or count to. It's a concept, an idea of endlessness. Infinity represents the idea that numbers go on forever. Think about it like this: you can always add one to any number. No matter how large a number you think of, there's always a bigger one. Get a massive number, add one, and then add one again and again. Still not the biggest because you can keep going. This process never stops. This is the beauty of infinity. It's an endless journey, a concept that stretches beyond our imagination. It's a journey, not a destination. Infinity is about the endless possibilities and the never-ending quest for more. But what about really, really big numbers? Numbers that are so large they boggle the mind? We're not just talking thousands or millions. We're talking about numbers that are astronomically large. We're talking numbers so big they're hard to imagine. Numbers that stretch the limits of our understanding. Get ready because we're about to explore the world of colossal numbers where even a billion is tiny. Prepare to have your mind expanded.
Let's start with a Googol. This whopper is a 1 followed by 100 zeros. It's more than all the grains of sand on Earth. And it's a real word, not just something made up. A mathematician's nephew came up with it. But hold on, because it gets bigger. Much bigger. A googolplex is a 1 followed by a Googol zeros. That's right, a Googol zeros. Writing it down would take more zeros than there are atoms in the observable universe. These numbers are huge, but they're still just the beginning. We're about to dive into the realm of numbers that make a googolplex look minuscule.
Buckle up, because things are about to get seriously large. We're diving into the realm of numbers so vast, they defy ordinary comprehension. Graham's number is so big it makes a googolplex look like a speck of dust. Imagine trying to compare a grain of sand to the entire universe. It's named after mathematician Ronald Graham and was used in a mathematical proof. This proof involves a problem in Ramsey theory, a branch of combinatorics. Here's the thing. Even writing it down is impossible with normal numbers. You'd run out of space in the universe before you could finish. We need something called up arrow notation. This special notation helps us handle such enormous numbers. It involves arrows and powers, and it gets complicated fast. Each arrow represents an operation that exponentially increases the number. Just know that each arrow represents a mind-bogglingly huge level of growth. The more arrows, the more incomprehensible the number becomes. Graham's number uses so many arrows it's almost impossible to comprehend. It's a number so large, it stretches the limits of human imagination. But trust us, it's massive. We're talking about a number that dwarfs anything you can think of. So vast, in fact, that if you tried to picture it, your brain would literally collapse into a black hole. The sheer size is beyond human comprehension. Okay, maybe not literally, but it feels like it could. The enormity of Graham's number is truly mind-bending.
Amazingly, Graham's number isn't the biggest number either. It's hard to believe, but there are numbers out there that make Graham's number look almost insignificant in comparison. There's Tree 3, a number so monstrous it makes Graham's number look tiny. Tree 3 is part of a sequence known as the tree sequence, which grows at an incredibly fast rate. It's based on trees, yes, the ones with leaves, and how they can be arranged. The complexity of these arrangements leads to numbers that are beyond human comprehension. It's even harder to explain than Graham's number. But trust us, it's colossal. Imagine trying to describe the size of the universe in a single sentence. Tree 3 is even more challenging to grasp.
And then there's the Busy Beaver function. This function is another mind-bending concept in mathematics. It uses the idea of busy beavers, theoretical ones of course, building dams to create gigantic numbers. The Busy Beaver function grows faster than any computable function. The higher the number inputted into the Busy Beaver function, the bigger the output. These outputs can be so large that they defy our understanding of size and scale. And some of those outputs are truly mind-boggling. They stretch the limits of what we can even begin to imagine.
So what's the biggest number? There may not be one. The concept of infinity means there's always a number larger than the one before. Every time we find a giant, someone might find one even bigger. It's a never-ending quest. It's like searching for the edge of the universe. Just when you think you've reached it, there's always more to explore. The journey and the mystery are part of the fun. The pursuit of understanding these colossal numbers is what makes mathematics so fascinating. The real takeaway is this. The world of numbers is infinite and awe-inspiring, full of wonder and endless possibilities. It's a realm where imagination meets reality. And that's a truly beautiful thing. The beauty of mathematics lies in its infinite possibilities and the endless journey of discovery.